Hey guys, we're here to find the change of thermal energy. So again, we're going to be able to find the change in thermal energy of a system. All right, so find the change of thermal energy. So we're looking for Q. That is our change in thermal energy, the kinetic energy and the mass of a substance. All right, so find the change of thermal energy for 10 kilograms. So that is a mass. 10 kilograms of a liquid with a specific heat, that's our C, of 3 joules per kilogram centigrade. When it cools down from 12 degrees Celsius, so that's our initial temperature, to 7 degrees Celsius, and that is our final. So again, we want to know the total change of energy, the total change of thermal energy when a 10 kilogram liquid that has a specific heat of 3 joules per kilogram centigrade, okay, or Celsius. Remember, specific heat talks about how much energy is required to raise 1 kilogram 1 degree Celsius. Okay, so this would take 3, so for every 3 joules, it would raise 1 kilogram 1 degree Celsius. That's what specific heat talks about. All right. So that's basically what we're looking for. We're trying to find the total change of all of the thermal energy. The average kinetic energy of the substance, which is the temperature, and its potential energy inside, dealing with the mass. All right, so we go to step 2. The equation that relates thermal energy, or change in thermal energy, is Q, change in thermal energy, equals our mass times our change in temperature. So that would be TF minus Ti, all times specific heat. Because we're both looking for number 1 and number 2 for the same thing, we do not need to rearrange this equation. And truth be told, you will not have to rearrange the equation at the freshman level. So let's find this change now. All right, let's plug in our numbers. So our change in thermal energy equals our mass, which is 10 kilograms, times our final temperature, which is 7 degrees Celsius, subtracted from our initial 12 degrees Celsius, all times our specific heat, which is 3 joules per kilogram centigrade. All right, there's a lot of stuff there, so I'm going to just kind of do that again. This time I'm just going to drop the units and keep the numbers. So we have 10 times 7 minus 12 times 3. Just dropping the units to help you guys understand. Okay, so 7 minus 12 is negative 5. 10 times negative 5 is negative 50. Negative 50 times 3 is negative 100. Whoops. Negative 150 degrees, or I'm sorry, negative 150 joules. All right, so let's talk about this. What this is saying is for an object, a liquid, we have 10 kilograms of it with a specific heat of 3 joules per kilogram centigrade. We don't know what this liquid is. We just know that's how much energy is needed to make it have a higher temperature, or going backwards, a lower temperature when it goes from 12 to 7. So because this object is cooling, it is losing energy. That is why it is a negative sign for our change in thermal energy. The object lost energy, its particles slowed down as it went from 12 degrees Celsius to 7 degrees Celsius. Again, that is why it's a negative 150 joules. Now, if this liquid got hotter, or should I say a higher temperature, then it would have been a positive Q.